You take off from Earth and park your spacecraft somewhere near the Moon. You're now almost 240,000 miles away from your home planet. That's almost 100 widths of the United States. Now you take out a giant hammer and an enormous chisel using the robotic arms of your spaceship. You place the chisel at the Earth's North Pole and strike its head with the hammer. Earth splits open like an eggshell, and you see it, another planet. It's Theia, and it's hiding inside our planet like a yolk in an egg. You'd need to go back in time 4.5 billion years to find out how it got there. This beautiful nebula will soon become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Soon this jigsaw puzzle of debris becomes too heavy and dense. The temperature inside the giant is rising. Soon it gets so high that it triggers a nuclear chain reaction. Another second and bam! There's an explosion so powerful that the shock waves travel far into dark space. And the blinding flash from this blast can be seen from the other side of the Milky Way galaxy. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. You're interested in a small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core, while the oceans of lava are gradually cooling down. But a few tens of million years after the Sun's birth, you notice a strange object hurtling toward Earth. It's Theia. This small planet was born at about the same time as Earth, and now it's following a crazy spiral trajectory at enormous speed. Scientists believe Theia was kind of a ball Jupiter and Venus played with. Venus was pulling Theia in one direction, then Big Brother Jupiter pulled it back. But the Sun makes up 99.8% of the mass of the entire solar system. That's why the star sets its own rules. It makes Theia move in almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Theia is the size of Mars and as wide as the Atlantic Ocean from New York to Portugal. A collision can't be avoided. Theia is traveling toward Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If the smaller planet crashes into Earth at a particular angle, Earth will most likely be torn apart, as well as Theia itself. The collision will cause a huge blast, visible on other planets even on a bright day. Nothing will be left but some burning dust and debris. Even if Theia touches Earth only lightly, it'll still knock out a chunk of our planet the size of Australia. But the collision with Theia happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shock wave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site. Soon, it gets filled with boiling lava. The remnants of Theia and the ejected fragments of Earth begin to orbit our planet. According to one version, these fragments form two moons. At first, they travel together, but one day, they get too close to each other and collide, forming one large space body. The other theory claims that all the shards start being pulled by the remnants of Theia. Sometime later, they form the moon as we now know it. At that point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Theia that we have different seasons and 24 hours in a day. Earth has lithospheric plates. These are enormous solid pieces that make up the crust of our planet. After the collision with Theia, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet. So, Earth gets some kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over nearly 4 billion years, simple single-celled organisms have been evolving into the life you see today. According to scientists, such a collision is a very rare event. The probability that somewhere out there, there's a planet like ours that has survived the same catastrophe is extremely small. This may be the reason why we are yet to find traces of other civilizations out there in space. Meanwhile, the remains of Theia are still here on Earth. Of course, it doesn't look like an entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see two huge lava blobs the size of entire continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Theia. They didn't mix with Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise those lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Theia might be on the moon. The Apollo space missions brought back many soil samples for analysis. Scientists have concluded that the moon is very similar to Earth in structure. People could drill deep down and take samples there. Then they'd analyze the blobs from Earth. If their structure matched, it'd be 100% proof that Theia did hit Earth 4.5 billion years ago. And that's how we got the moon. But for the time being, Theia remains somewhat mysterious. Scientists are still not sure that the planet actually existed. The whole idea perfectly fits the model of the moon's creation. But in fact, this incredible collision may have never happened.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
Now you travel 41 light years away from Earth to the planet 55 Cancri E. It's about twice the size of Earth and 8 times heavier. You take out your giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than that of Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon. Its structure changes. First, it turns into graphite. Some more pressure, and graphite turns into diamond. On Earth, diamonds form at depths below 60 miles, where the pressure is 50,000 times greater than on the surface. The temperatures there rise over 1,000 degrees, which is as hot as fire. Diamonds are ejected closer to the surface in volcanic eruptions. Still, people have to dig mines 1,500 feet deep to find these beautiful gems. The Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now imagine a diamond the size of an entire planet. You decide to fly back to the solar system. Your destination is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% the mass of Earth. Its surface is enclosed in an icy crust. It's about 19 miles thick. But what if you crack this crust with your giant hammer? Wow, Europa is completely covered in water. It's freezing here, 3 times colder than at the North Pole on Earth. The water turns into ice almost instantly, but the ocean beneath the surface is still liquid. Europa interacts with Jupiter gravitationally, just like the moon with Earth. This creates tidal forces and heats Europa's core. The core melts the ice around it. The result is a huge ocean, 2 to 3 times larger than all of Earth's oceans combined. Scientists believe that water is the basis of life. It may mean that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans. The water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria may live there. Europa is almost the same age as Earth. This means there's been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They may be building big cities and dreaming of conquering space right now. But the only thing people can do at the moment is send a probe to Europa and find out if life is possible there.
Deep inside our planet, there are 2 massive blobs of rock that have puzzled scientists for years. They sit deep inside, opposite each other. One lurks under the Pacific Ocean, the other under Africa. And they're so weird, they even make seismic waves slow down. Their actual name is large, low-velocity provinces, but they're just 2 enormous, mysterious blobs of rock, bigger than continents, stranger than anything else inside the Earth, and so dense they might be leftovers from another planet. Until recently, no one knew what they were, where they came from, or why they even exist. These mysterious blobs could hold the secret to Earth's deepest forces, powerful enough to shape earthquakes, drive volcanic eruptions, and even influence the evolution of life itself. And now, we might finally learn the truth about them. These geological monsters are hidden about 1,800 miles beneath the surface. Each one is 100 times taller than Mount Everest, so vast they defy explanation. Now, at first, scientists thought these were primordial remnants from Earth's early days. Maybe something giant smashed into Earth about 4.5 billion years ago, and this impact formed both the Moon and these blobs. Scientists believe it could have been a planet named Theia, a Mars-sized planet that existed somewhere around the asteroid belt and slammed into Earth back in the day. Others believe it could be something much more familiar, old chunks of Earth's crust. Perhaps they got pushed deep into the mantle by the movement of tectonic plates. And now, a new study shows that these blobs are massive piles of oceanic crust that have been sinking into the Earth for billions of years. They could have formed from the stuff that sinks into Earth when tectonic plates collide. Over 1 billion years, pieces of ocean crust could have been swallowed by the mantle. Eventually, they collected into 2 massive regions deep inside the planet. But even though both blobs form the same way, they aren't identical. There's this place called the Pacific Ring of Fire, a giant loop of volcanoes and earthquake zones around the Pacific Ocean. Well, the Pacific blob doesn't just stop growing and changing because it's constantly being fed fresh rock from that place. Tectonic plates crash into each other, and one plate sinks beneath another, pushing old ocean crust deep into the Earth. Since this keeps happening, the Pacific blob is heavier, denser, and more active than its twin under Africa. It's like a giant hot rock factory, constantly getting new material and reshaping itself over time. The African blob is much older and quieter than the one under the Pacific. It doesn't get fresh rock pushed into it as often. That's why, over time, it has blended more with the surrounding mantle. Since it's less dense, it behaves differently. It rises higher into the Earth's mantle, stretching 340 miles closer to the surface. And that might be why Africa has so many powerful volcanoes and rift valleys today. The biggest question is, how do they keep evolving? Scientists think that huge columns of hot rock, called mantle plumes, might be pushing up from deep inside the Earth, helping to drive the movement of tectonic plates in the Pacific. If they're right, then these giant underground blobs aren't just sitting there. They're almost alive in a way. They'd be constantly changing and shaping the surface of our planet. But why do they even matter? Because these weird underground structures may be shaping Earth's surface in ways we don't fully understand yet. You see, first, they might influence Earth's magnetic field. That's because they affect how heat moves through the mantle and core. They might also hold clues about the history of plate tectonics. Studying them could help us figure out when subduction began on Earth, whether it was over 4 billion years ago or much more recently. These guys might also be secret puppet masters behind volcanic activity. There's a theory that blazing hot rock from deep inside the Earth, the same kind that creates volcanic hotspots, might be rising straight from the giant blobs in the mantle. Some of the biggest volcanoes on Earth, including those in Hawaii, Iceland, and Yellowstone, sit directly above the suspected rising plumes from these blobs. If these blobs are fueling these volcanoes, then they could be responsible for shaping Earth's continents, climate, and even mass extinctions throughout history. And well, that's horrifying. That would mean that these giant structures might burst through Earth's crust one day, unleashing catastrophic supervolcanic eruptions, and these eruptions would last for millions of years. Beneath the Earth's surface also lies monsters unlike anything else on this planet – supervolcanoes. They're so massive, so destructive, and so rare that no human has ever witnessed one erupt. A regular volcanic eruption can be terrifying. Lava spewing into the sky, ash choking the air, entire cities buried under fire and stone. But a supervolcano? Well, that's something else entirely. A supervolcano isn't just big, it's a category of its own. Their eruptions rip apart the Earth itself, creating massive craters called calderas. Some of them are over 30 miles wide. A regular volcanic eruption might spew out a few cubic miles of lava and ash. A supervolcano unleashes more than 240 cubic miles of material. That's enough to bury an entire continent in ash. An eruption like this would be newsworthy, to say the least. First, a wall of fire would blow up into the sky. Ash would block out the sun for years, dropping global temperatures. Entire countries could be buried under meters of ash, making farming impossible. Famine, extreme cold, and toxic air could wipe out entire civilizations. It wouldn't just be a local disaster, it would be global. In fact, two of the worst mass extinctions in Earth's history, where almost all life was wiped out, might have been caused by supervolcanoes, not asteroids. The biggest and most horrifying one was at the end of the Permian period. Literally, about 90% of all marine species and 70% of land species went poof. Scientists have counted about 20 supervolcanoes on Earth today. The most famous ones are Yellowstone in the US, Toba in Indonesia, and Topao in New Zealand. Now, the last time Yellowstone erupted was roughly 2 million years ago. It released almost 590 cubic miles of material, enough to bury a city like New York. That was just one of 3 Yellowstone supereruptions. The most recent supervolcano to erupt was Topao in New Zealand. This happened about 26,500 years ago. But supervolcanoes don't just destroy, they reshape the entire planet. About 74,000 years ago, the Toba supervolcano erupted in Indonesia. Some scientists believe it triggered a volcanic winter that lasted an entire decade. There are also theories that suggest that this eruption nearly wiped out early humans. It reduced their numbers to just a few thousand survivors, although that's just speculation. Either way, we know for sure that supervolcano eruptions have changed the course of history. So, how do we prepare for them if this could happen at any moment? Well, scientists monitor volcanoes constantly, looking for warning signs. It could be stuff like rising magma, ground swelling, earthquakes beneath a volcano, changes in gas emissions, and so on. The problem is that while we can predict short-term eruptions, the long-term ones are still a mystery. Yellowstone last erupted 630,000 years ago. It's literally overdue for another eruption already. But volcanoes don't work like clocks. Just because one erupted in the past doesn't mean it will definitely go wild again, and the time between eruptions could be random. Scientists think Yellowstone could erupt again, but it might be just a small lava flow instead of a super eruption. Are we ready for a super eruption if it happens? Probably not. Scientists say we're more prepared for an asteroid strike than a supervolcano eruption. When Hunga Tonga Hunga Ha'apai erupted in 2022, it cut off communications, caused tsunamis, and filled the sky with ash. And that was only a magnitude 5 eruption. A supervolcano would be orders of magnitude worse. So, good luck sleeping at night knowing these guys will erupt again. Maybe tomorrow, maybe in 100,000 years. Nah, don't lose sleep over it. This is Earth, 335 million years ago. I wasn't around then, but there's just one supercontinent, Pangaea. See? Let's watch it shift around and fast forward. Okay, here we go. It just split into 2 huge pieces. Australia goes this way, North and South America go that way. Africa, Asia, Europe, forming, and there we go. The planet as it is today. Let's keep going. I mean, the continents are always on the move. Over time, some of them will crash into each other. Others will break apart. But that'll take about 100 million years. Better put it on super fast forward. 100 years from now, humans keep spitting carbon dioxide into the atmosphere, and the planet's already warmed up a bunch. The world's ocean levels have risen about 4 feet. The Bahamas? They've totally disappeared. 200 years from now, the Earth's population is about 19 billion people. The climate's gotten even warmer. We're packed in like sardines over here. New medical tech makes it possible to live to 180. But why? Fossil fuel reserves of oil and gas? Long gone. Oh, and the continents have drifted over 16 feet. The Voyager 1 space probe's about to enter an asteroid cloud at the edge of the solar system. It's the most distant man-made object in the universe, I guess. 1,000 years from now, thanks to better quality food, humans are now 7 feet tall on average. Technology solved the pollution and fuel shortage problem. Humanity's doing just fine. Robots do all the work, we just play around all day. Ocean levels have crept up another 10 feet. Islands like the Seychelles, Maldives, Galapagos, and many others have gone underwater. Denmark, the Netherlands, Eastern England, Thailand, and Vietnam are only partially underwater. There's been a huge human migration these last 100 years. Fast forward about 5,000 more years, and it's the year 8113. Humanity's getting ready to open the crypt of civilization. It's a hermetically sealed room in Georgia, in the States. Bad Georgia. It was created in 1940, and it's full of about 800 books on microfilm, recordings of famous people's voices. It's also filled with bits of technology from that time, like a toaster, a radio, and a typewriter. Some awesome people created the crypt of civilization in case humans experienced a major catastrophe in the distant future and had to rebuild civilization from scratch. We'd all go back to using typewriters. 15,000 years from now, our planet has changed its tilt, and the Sahara Desert is now a tropical paradise. Years of rain turn the dry desert into a wild jungle. 30,000 years from now, the Voyager 1 space probe has finally left the asteroid cloud at the edge of our solar system. If it doesn't collide with anything, it'll be flying in the dark, wide-open outer space for a very long time. 50,000 years from now, the climate's changing a lot. The temperature on Earth is beginning to drop, and we are approaching the beginning of a new ice age. The radio signal with a special "Hello, all you aliens out there" message sent into space in 1974 has reached its destination. The message contained the human number system and data about our DNA and our solar system. If there was someone on the other end to receive this signal, we might have a response from them. 100,000 years from now, one of the largest known stars in our galaxy, Canis Majoris, explodes with enormous force. The explosion of this supernova can be seen from Earth, even during the day, and the nights are much brighter because of the new strong glow in the night sky. What's new on Earth? Supervolcanoes start erupting all over. These volcanoes spew colossal amounts of lava and ash everywhere. Thick black clouds cover most of the sky. This prevents the sun's rays from reaching the ground, and the temperature on our planet drops even lower. Humans mostly live underground anyway, so it's no big deal. Because the stars are gradually moving in different directions, the usual constellations are starting to change shape. Soon, we'll need to come up with totally new constellation names. 250 years from now, a new island's on the map. Back in 2021, it was just an underwater volcano somewhere in the Pacific. After thousands of years of spouting out lava, it finally reached the ocean surface and busted out in the cool, fresh air. Not much growing on it yet. Niagara Falls has long since disappeared, and Lake Erie and Lake Ontario have teamed up to form one huge super lake. 300,000 years from now, the triple star system WR104 is about to explode. It's spinning crazy fast, and there's a chance that radiation from the explosion could eventually reach Earth. That would do a lot of damage to all life on our planet. Voyager 1 reaches the brightest star in the night sky, Sirius. Not a very funny star at all, it's really Sirius. It's 8.6 light-years from Earth. 500,000 years from now, scientists are pretty sure that a huge meteorite could fall to Earth any day now. It might be even the size of 8 football fields. The impact of such a massive meteorite would cause an explosion so powerful that its sound would be heard on every continent. That would be followed by super strong earthquakes and tsunamis higher than the Brightside Empire municipal building tower thingy. Okay, I just made that up, but who knows what we'll be building in the future. 1 million years from now, the rogue star Gliese 710 comes very close to our solar system. We're surrounded by a huge shield of asteroids called the Oort cloud, and the rogue stars beginning to affect the asteroids hanging out in there. It grabs them, spins them around, and throws them toward the center of our solar system. Comets start to fall on our planet all the time, big ones, causing more tsunamis and earthquakes. 10 million years from now, the Red Sea is gradually expanding into the East African Rift. Africa is now divided in two by a new oceanic gulf. The human DNA molecule has completely decomposed. But it's no big deal. We've become totally digital, without any pesky aging problems. The really cool thing is that other animals have evolved a lot and changed ridiculously. Thanks to a simple interface, we're actually able to talk to dolphins, chimps, dogs, and cats. Turns out cats aren't grumpy, they're just busy contemplating life. 25 million years from now. The San Andreas Fault has been crazy recently and has caused the Gulf of California to flood the Central Valley. There's a new sea on the west coast of North America. 50 million years from now, Africa just collided with Eurasia. The Mediterranean Sea is totally gone. There's a new tallest mountain in the world. Its name? Mount Everest, of course. Australia's continuing its journey north. It already collided with Southeast Asia a few million years ago. The few human colonies still left on Mars need to do some serious packing. Phobos, one of Mars' moons, is beginning to orbit at a lower and lower altitude. That's not good. It's about 14 miles wide, so that's going to be unpleasant. 60 million years from now, the Canadian Rocky Mountains have completely eroded. It's just one gigantic flat plain. 80 million years from now, all that remains of Hawaii is one island. All the others have long since gone underwater. But just next door, a whole new chain of Hawaiian islands has emerged. Finally, 100 million years from now, we made it! The Atlantic shrinking down to nothing. The Americas are almost rubbing up against Africa. Africa's already merged with Eurasia. We've got ourselves a supercontinent again. Hello, Pangaea Proxima. All traces of human life are gone or buried deep underground. The movement of the continents has destroyed tunnels, roads, buildings, bridges. Animals and plants now reign supreme on Earth. So, where are all the humans? Well, remember we made the jump to digital about 90 million years ago? Things are still going strong. There are trillions of human minds living on a huge hard drive on a spaceship orbiting Earth. The super low space temperature is good for keeping the drive nice and cool. We have millions of different societies, languages, and cultures just like we had 100 million years ago. The only difference? We're all little ones and zeros in a huge digital universe that we created. And yes, there's still football.
Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up! Our first destination is a gas giant called Crust 2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. Crust 2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of Crust 2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes Crust 2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light-years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light-years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blow-torched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called Koi 55b, or Kepler 70b. This planet is very far away from us, 4,000 light-years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, Koi 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with Koi 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But Koi 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned Koi 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems, but this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments.
Jupiter's gravity shattered a huge comet. It wasn't enough for the space monster. A real catastrophe happened. The shards didn't fly in different directions. They lined up and rushed towards Jupiter like the rail cars of a train. 21 fragments up to 1 mile in diameter burst through Jupiter's atmosphere. Fireballs at the speed of 37 miles per second bombarded the planet's shell. They heated the space around them to 50,000 degrees Fahrenheit. That's higher than the temperature in the sun's upper atmosphere and 312 times hotter than you need to boil an egg. Well, I'm not hungry anymore. The impact was like from a rock falling into a pond. The meteorite fragments formed giant plumes on the surface of Jupiter. Substances from its lower atmosphere rushed upwards. The process generated a tremendous amount of energy. Overheated streams of fire shot into the stratosphere. The monsters left behind them glowing plumes 1,900 miles long. That's greater than the distance between New York and Texas. Dark bruises appeared at the side of the blows. They were about the size of the Earth. Comet Shoemaker-Levy 9 was the name of the violator of Jupiter's boundaries. The collision of celestial bodies happened in July 1994. It was a scientific sensation. For the first time in human history, a catastrophe of this magnitude was observed. The attack raised an important question for astronomers. Why is Jupiter unlucky? Space monsters attack it thousands of times more often than the Earth or any other planet in the solar system. All right, let's see. You decide to board a starship and travel to the mysterious Jupiter. A space probe would need 2 years to get there, but your starship is faster. You'll be there in... Great, the journey only took a second. Jupiter is actually big. It could fit 1,300 Earth-sized planets in it. It looks beautiful thanks to gas clouds. This planet has no solid surface, but there's a strange stain on its surface. It looks like a huge eye that can fit 3.5 Earths. This storm will scare anyone. It's 10 times higher than Everest, and the wind rushes at a speed of 300 miles per hour. It's been going on for 350 years. You wouldn't hide from such a storm in a car, so it's good you're in a starship. If all the planets of the solar system merged into one superplanet, the new object would still be 2.5 times smaller than Jupiter. Large size also affects gravity. Spacecraft use Jupiter as a springboard to jump. The giant's gravity increases their flight speed and helps them reach their target faster. Gravity has turned the planet into a magnet for comets, asteroids, and dangerous space debris. Jupiter is a true space superhero. Its gravity shield takes a hit and deflects space monsters that fly into the inner solar system. The dinosaurs don't agree, but more on that a little bit later. What if Jupiter was swallowed up by a giant vacuum cleaner tomorrow? I can only say one thing: we'd have huge problems. Without a giant shield, thousands of comets and asteroids are attacking the planet much more often. Most of them burn up in the atmosphere or aren't large enough to affect us. But there are also larger comets and asteroids. After their collision with the Earth, you can say goodbye to all life on the planet. For example, in 2009, a celestial body crashed into Jupiter. It left a bruise the size of the Pacific Ocean. It's scary to think what traces it would leave on our planet. Most likely, the Earth would turn into a fireball. But recent research from astronomers suggests that Jupiter isn't such a nice guy. On the contrary, it's a bad guy with a slingshot that shoots comets at the Earth. A physicist used computer simulations. He found that Jupiter is equally likely to deflect and send comets toward the Earth. The giant attracts potentially dangerous objects and only partially protects us. It's already tried to knock out our planet many times. 66 million years ago, a cosmic body 10 miles in size crashed into the Earth. The energy of the impact set the surface of the planet on fire. It caused a huge earthquake and tsunami. A fiery rain fell from the sky on the Earth. There were millions of tons of debris and dust in the atmosphere. They stopped the sun's rays from reaching the planet. The nuclear winter began. This disaster led to the extinction of the dinosaurs. Scientists have named this space criminal Chicxulub impactor. Computer simulations of scientists at Harvard University showed where it came from. Chicxulub wasn't an asteroid, but a comet. This means that the core of its body wasn't stone and metal, but ice, dust, and frozen gas. It resembled a dirty snowball flying through space. The meteorite wasn't going to set fire to the Earth, but Jupiter intervened in the plan. It threw comets in our direction. In 1770, Lexell's comet appeared near the Earth. Our planet and this object were separated by only 1.4 million miles, close to nothing in space terms. Lexell's comet came closer to Earth than any other comet in human history. The object could have stopped life on Earth. The comet flew too close to Jupiter. The giant caught it and sent it in our direction. Now, this isn't a very good move for a superhero that protects the solar system. After 3 years, the comet went past us. It flew 2 times around the Sun and returned to Jupiter like a boomerang. This time, the giant pushed the comet out of the solar system. But let's not blame Jupiter. Scientists believe that without this gas giant, life on Earth would most likely never have happened. Jupiter sent meteorites toward Earth, which carried organic molecules and water with them. They were the building blocks from which earthly life began. Nobody knows if comets would come with a valuable cargo without Jupiter and its dangerous gravity. If you fly away from Earth to the center of the solar system, you'll see the Sun. 8 planets are flying around this star. There's a belt of more than 1 million asteroids between Mars and Jupiter. One theory says there was only the Sun at the very beginning of the solar system's existence. Clouds of stone and dust surrounded the star. These particles attracted each other and formed planets over millions of years. Jupiter didn't want any new neighbors. Its powerful gravity prevented rocks and dust from uniting into planets. They remained asteroids and gathered in a belt inside the solar system. If today all the asteroids merged into one planet, we'd get a cosmic body that would weigh only 4% of the mass of the Moon. Previously, the belt was densely populated, but Jupiter's gravity threw 99% of the asteroids to other places in space. Jupiter isn't the only one that plays a role in the development of life on Earth. Our main assistant is the Moon. It's the only natural satellite of the Earth. Jupiter has 79 satellites, and every year there are more and more of them. Jupiter is also surrounded by rings, but they aren't as beautiful as Saturn's and are practically invisible. The rings are composed of small black particles. This is the dust that the meteorites eject into space after colliding with the moons of Jupiter. The Moon is responsible for the ebb and flow of the ocean. It regulates the life of bees, fish, birds, and amphibians. Even you feel the influence of the Moon every day. Changing the brightness of the disk in the night sky regulates the level of melatonin in your brain. This hormone is responsible for circadian rhythms, which are important for healthy sleep. The Moon came about thanks to another catastrophe, like many other things in space. Millions of years ago, the Earth looked like a ball of hot lava. There was no water or air. It was enveloped only in carbon dioxide and nitrogen. At this time, another planet the size of modern Mars crashed into the Earth. Scientists named it Theia. At a speed of 8,900 miles per hour, it collided with the Earth. The impact of incredible force threw millions of tons of material into space. The debris gathered into a ball that became known as the Moon. Scientists have almost solved the mystery of the Moon, but they don't know if there's a solid core in the middle of Jupiter or if it's dense hot soup that hangs in space. Jupiter has the largest ocean in the solar system. It's made of liquid hydrogen, not water. If Jupiter were 80 times more massive, it would turn into a bright star. Jupiter is a unique place that will never be home to humans. The pressure inside the planet is 2 million times greater than on the surface of the Earth. Extreme pressure and temperature would ruin any spacecraft that's gone too far. I guess that means Jupiter would have a crush on you.
84 million years ago. Many modern mammals, birds, insect groups, even the first flowering plants are already there. Dinosaurs are still roaming around. They have around 20 million years left before the asteroid. T-Rex, a fearless hunter, becomes the king of the dinosaurs. In the Earth tilted by 12 degrees. Picture our planet as a chocolate truffle. The shell is hardened, the center is viscous, with semi-solid matter. Its top layer, the crust, consists of tectonic plates that are like puzzles. Continents and oceans come on top of these plates. 84 million years ago, the mantle and the crust started rotating around our planet's outer core, then going back. If you'd been able to see it from space, it would have seemed like the entire planet has tipped over on one side. Today, it would have moved New York City to where Florida is. Let's say our planet is like a spinning top. It whirls perfectly if the weight on the top is evenly distributed, but if you move some of the weight to one side, it makes it tilt. It may have been caused by the moving of the tectonic plates and one of them sinking under another. We might be drinking water older than our solar system. Some scientists think the water we have on Earth may have come from ice specks that were floating in some sort of a space cloud more than 4.5 billion years ago. Lakes aren't always peaceful and relaxing. They can also explode. It happens when there are volcanic gases under the surface that can burst, rise to the surface, and cause big damage. The Earth's rotation is slowly going through time. Every year, the Moon gets a little bit of energy from our planet and slowly drifts farther away from it. These two things are making our day longer, but really slowly, around 1.4 milliseconds every 100 years. That means when dinosaurs were around, the day was 23 hours long. Our planet used to be purple. One theory says ancient microbes didn't rely on chlorophyll to absorb the sun, but on different molecules. They absorbed green light and then reflected back a nice purple color. Every time you take a dip in the ocean, remember you're swimming above more than $700 trillion worth of gold. Not on the ocean floor waiting for someone to get it out, but in tiny particles dispersed in the water. The deepest place on our planet is the Mariana Trench, a spot in the Pacific Ocean, 36,201 feet under sea level. But the deepest place that's not covered in the ocean is in Antarctica. Technically, it's hidden below thick and deep layers of ice, goes more than 8,300 feet below sea level. There are 60 tons of dust falling from space to our planet every day. You probably inhale a pretty good amount of this cosmic dust while just going to work. It's dust, small particles from comets, meteorites, and some other space bodies. Dalo, Ethiopia, is the hottest inhabited place on our planet. Between 1960 and 1966, the temperature was 106 degrees Fahrenheit, and even in the wintertime, the temperature goes up to 98 degrees Fahrenheit on average. 8 minutes and 20 seconds. That's the time sunlight needs to travel from the sun to our planet. It's still not that much compared to what it takes for the light to reach Pluto, 5.5 hours. Almost 70% of the fresh water we have in this world is held in ice sheets and glaciers. More than 96% of the total amount of water on Earth is in the oceans. The Earth is like some sort of big magnet. Its inner core is actually a sphere made of solid iron, with liquid iron surrounding it. All those variations and changes in density and temperature create some sort of force, which makes the iron produce electrical currents. They are lined up by the planet's spin, and together, they create a magnetic field. There are many stars in the Milky Way, 100 billion, but way more trees on our planet alone, around 3 trillion. You can tell how old the tree you're looking at is by its rings. They can also tell you more about the conditions of a given year, too. When these rings are thin, there was a drought, while the thick ones say it was a rainy period. Earth is a magical planet where even rocks can walk, at least some of them, in Death Valley, California. They leave trails so you can record the path they've passed. Some of those biggest rocks have left tracks behind up to 1,500 feet long. Smooth-bottomed rocks wander around, while those with rough surfaces tend to leave straight tracks. The world that surrounds us consists of atoms, and they seem to be solid. But 99.99% of them are just empty space. An atom is just a really small nucleus and a cloud of electrons surrounding it. These electrons are particles, but they act like waves. They don't exist in one point but are spread over a range of probabilities and occupy lots of space. Take the empty space in our atoms, and all the humans could fit in a really tight space like the volume of a sugar cube. Australia is slowly shifting north, 2.75 inches per year because of tectonic movements. Australia is one of the top continental tectonic plates that move faster than others. You'd need 400,000 moons to reach the level of brightness the sun has. Sounds a lot at first, but the moon only reflects the light coming from the sun. It doesn't make its own. And even though that's not enough, its brightness depends on the exact angle between the sun, moon, and the Earth. The planet we live on used to have 2 moons, or at least some scientists believe so. They figure the side of the moon that faces the Earth is relatively flat and low, while the other side is way thicker and crustier. The theory says that there used to be the second moon that collided with the thicker side. Some believe there's still a second moon. It could be not a giant space body we see clearly in the sky, but some sort of a small asteroid pulled into the Earth's orbit. Air doesn't mostly consist of oxygen. Almost 78% of it is nitrogen. If you want to see some pretty steep rocks, go to Canada, Auyuituk National Park. It has the biggest vertical drop in Canada, the tallest and the steepest cliff, with 105 degrees of overhang and 4,000 feet of rock. A team of 4 American men finally made it to the top in 1985, although there were 30 attempts for that before. It took them 33 days to get up. The Pacific, Atlantic, Indian, and Arctic are the 4 world's oceans. The 5th is confirmed to be the Southern Ocean. It's not defined by the continents around it, but by its Antarctic current that goes from west to east. Research shows this current was created more than 30 million years ago when South America and Antarctica had separated. This allowed water to flow around the bottom of the ocean without any barriers. Melting glaciers and ice sheets means more water in the oceans. It adds the extra weight of all that liquid pressing down the sea bottom, making it sink. The Earth's surface looks solid and kinda permanent, but every 500 million years, it goes through a process of regeneration. Tectonic plates crash into each other. Continental crust creates pressure on the oceanic crust, and that pressure activates the volcanoes. Through time, all this results in regenerating and replacing a majority of the Earth's surface, just like our body regenerates skin cells, replacing old with new ones. Out of all planets in the solar system, Earth is the only one with the outer crust that's broken up into huge surfaces we call tectonic plates. This is an important process that allows the formation of oceanic trenches and mountains, and also helps with protecting the Earth. When microscopic planets that live in the ocean are gone, they fall down to the bottom. The remnants go back into the interior of our planet and get recycled, and eventually end up in the atmosphere, protecting us from overheating and turning into Venus, the hottest planet in our solar system.
Look up when the sky is clear at night. You'll see thousands of tiny bright dots there. It may seem like they're fixed in one spot, but in reality, they're constantly moving. In 100,000 years, there won't be a constellation with the same shape or pattern we know today. And think about all those red dwarfs, small stars, planets, space bodies we can't see with the unaided eye. Red dwarf stars are especially cool. They're usually about half the size of our sun, and mostly 1/10 as bright. They may not be the brightest things in the sky, but they live for a very, very long time. Nuclear fusion reactions happen deep in star cores. That's what makes them shine. Large stars release huge amounts of energy, burning their stellar fuel. But such stars tend to burn all their fuel in only a couple of million years. Stars like our Sun usually live for about 10 billion years, but red dwarfs don't use that much of their fuel. Their light is not so powerful, and they don't require much energy to support their existence. They're like energy-efficient cars. That's why they can last hundreds of billions of years. Some of the smallest ones may live for up to 10 trillion years. Most hydrogen in sun-like stars remains unspent. There's more of this gas in the atmosphere rather than in the core of such stars. This means most hydrogen doesn't take part in the fusion reactions. But it's different with red dwarfs. They circulate plasma throughout their entire bodies. These stars pull fresh hydrogen reserves from their outer layers into their core. That's what keeps fusion reactions running. One day, in the distant future, stars like our Sun will run out of fuel and shut down. The universe will be full of small red dwarfs. They won't have enough energy to shine and brighten the space around them. Our descendants, if there are any, will inherit a dim, dark cosmos. As it gets older, the Sun will balloon to a size where it will destroy nearby planets. First Mercury, then Venus, and then us. On the other hand, Earth will probably survive, but barely and not for long. The Sun will burn it to a crisp when it gets closer. The outer planets of our solar system will also survive, but they'll move even farther away into space. The Sun will lose some of its mass while increasing in size. Its gravitational pull establishes the orbits of the planets. When our star becomes less massive, the pull of its gravity will become weaker, and the outer planets won't have such a strong connection with the Sun. Our solar system is not isolated. There are many other stars in our galaxy. Within 30 billion years, stars that travel nearby will mess with our outer planets, enough to rapidly launch some of the biggest ones out of the solar system altogether. The last planet to stay will stick around for a while longer, maybe even 100 billion years. But even that one will eventually end up kicked out of the solar system. There's a theory claiming that we got most of the water on our planet from ice-laden meteorites and comets, frozen balls of ice and dust. As they crashed into the early Earth, they probably brought water, which was necessary to develop life. But those very same objects that might have created life on our planet could also be its end. This is not a matter of if, more a matter of when. And scientists think it's very likely that an asteroid or comet big enough to wipe out life on Earth will smash into our planet. But it'll happen in the distant future. And fortunately, we have the technology to predict such things and react on time. But there are other cosmic collisions we can't avoid, no matter what we do. Andromeda, our neighboring galaxy, is moving toward the solar system at a speed of 68 miles per second. There are 2.5 million light-years between the Milky Way and Andromeda, so luckily our neighbor won't cover that distance anytime soon. It'll only happen in around 4 billion years. Such a collision of two galaxies might lead to real chaos for our descendants, if any of them are still living on Earth, that is. The two galaxies will slide past each other. Then they'll draw apart until the gravitational force starts pulling them back together. As they merge, they'll both lose their disk-like structure and form one big elliptical galaxy. It's already got the nickname Milkomeda. The Milky Way as we know it today won't exist anymore. Space is in constant motion, changing all the time. Scientists have a couple of possible scenarios of what might happen with the universe in the future. Number 1, the Big Rip. This theory claims that the universe will expand infinitely. At one point, the pull of the expansion will get stronger than the gravitational force keeping it all together. If this happens, it will tear apart galaxies, stars, black holes, and all other space bodies, including Earth. The universe will turn into a bunch of disconnected particles. Until about 5 billion years ago, the universe was expanding slowly because of its powerful gravitational pull. Then its growth sped up. Some experts say it happened because of the effects of dark energy. Dark energy is a mysterious force that makes up almost 70% of our universe. This force pushes it to expand faster rather than slowing it down. So, in the case of the Big Rip scenario, dark energy will win over gravity to the point where it will be able to rip apart individual atoms. Scenario number 2, the Big Crunch. There's a possibility the universe will get to the point where it'll stop expanding. Gravity will become a dominant force. It might even reverse the expansion of the universe. Then, the cosmos will start shrinking, making planets, stars, and even entire galaxies collide. In the end, the whole universe will collapse in on itself. Once everything compresses into one infinitely small point, which is something called the Big Crunch, the universe may start expanding once again. Theory number 3, the Big Freeze. Brr. In this scenario, entropy will grow until it reaches its maximum value. Entropy is basically the idea that everything in the universe declines into disorder at some point. Once entropy gets to its maximum, the heat in the system will be spread evenly. The universe will then disappear because there won't be any room for heat to exist. Any mechanical motion inside the universe will stop. The cosmos will be so empty and gas will be so thin that no new stars will be able to form or shine again. In such a cosmos, time is just an endless void. Nothing ever happens with planets, stars, or living beings. The entire universe is frozen, dark, and motionless because there's no energy that can make things start working again. Many, many billions of years after the last stars burn out and fade, black holes will send a message that the universe has come to an end. Black holes are areas with extremely strong gravitational pull, so powerful that nothing can escape it. They can be as massive as 100 suns. As for supermassive black holes, their mass can be greater than that of 1 billion suns. You can find such giant black holes at the center of most galaxies. Like everything else, black holes will experience the same end. But when their moment comes, they won't gently disappear into the night. Black holes will go away in enormous bursts of fireworks, lighting up the universe in the last moments of their existence. It will be the end of the entire era. Black holes usually survive by gobbling down the stars and gas that come close enough. Their gluttony is the main feature that gives them away. In most cases, there's an accretion disk around a black hole. That disk is made of all those materials and particles it's torn apart and is pulling inside, similar to when water swirls down a drain. As the materials and particles draw closer, they start to move faster and faster. This generates heat, which makes the accretion disk glow, which again gives away the black hole. Yep, black holes aren't that great at hide and seek. Things that cross a black hole's event horizon, which is also called the point of no return, are lost forever. But Stephen Hawking had a theory that you might be able to escape from a black hole. There are particles moving even in a vacuum. Let's say one particle has positive and one has negative energy. If they both come close to a black hole, there's a chance that one will fall into it while the other will escape. That means the black hole has radiated the particle away. And this particle has taken some of the black hole's mass with it, which is why the black hole may start shrinking. As it begins to evaporate, it loses its mass and slowly becomes smaller. More and more particles start leaving until all the energy that's left behind escapes all at once. In the final tenth of a second, there will be a giant flash of energy and light in a very, very small region of space. And then, it's all gone. For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination, and they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system, but this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
You're a seismologist working at a geological observatory. In the morning, you check the equipment that monitors seismic activity and adjust the instruments. Then you inspect the movements of tectonic plates. Suddenly, one of the devices shows a strange signal. It's like a small earthquake. You make a record of this push and continue working, but the signal repeats again. A little time passes and the devices fix it for the third time. You understand that this is not an earthquake because the signal is too weak for this. It repeats every 26 seconds and resembles a pulse. The human heart pulses close to the center of the chest. The pulse of the planet also comes from its center, the equator. You call other specialists and tell them about the unusual phenomenon, but no one knows what it is. Also, you can't determine the source of the pulse. You arrive at the place where the vibration comes from and find nothing. The ground still pulses under your feet, but it's impossible to figure out the reason. In the 1960s, the pulse called microseism was discovered by seismologists in the US. More than 50 years have passed, but scientists around the world still don't know the nature of this phenomenon. It looks as if our planet has a heart hidden inside its crust, beating every 26 seconds. According to researchers, this heart may be located in the southern or equatorial part of the Atlantic Ocean in the Gulf of Guinea. This area is called the Bight of Bonny. Every winter, the pulse becomes stronger. Then it weakens again by the summer. When scientists began exploring this place, they put forward a theory that the ocean could create the pulse. Waves hit the continental shelf of the planet. That impact deforms the ocean floor. A human hand hitting a table works on the same principle. Sit on one side of the table and put your hands on it. Let someone else hit the table from the opposite side. You will feel a vibration. Ocean waves hitting the coastline create a similar effect. Someone may object that there are waves all over the world, not only at the equator. Yes, but that's where the sun heats our planet the most. Solar energy causes powerful storms and winds and accelerates ocean currents and waves. Also, in 1980, geologists found out that Earth's tremors became stronger during storms. In other words, when waves hit the shore with more power. Not all scientists agreed with this theory. Some researchers believe the planet was pulsating because of the seismic activity. It was coming from a volcano located on one of the islands in the Bight of Bonny. The place where the pulse was the strongest is close to the volcano. But further observations showed that the Earth's tremors happened in all parts of the Gulf of Guinea. That's why scientists can't prove any of these theories. Our planet pulsates not only from within. Earth is surrounded by a thin luminous halo. It's constantly changing its shape and shimmering with different colors. If you look at our planet using special equipment, you'll see that Earth is inside an uneven pulsating bubble. It's located at an altitude of 50 to 400 miles above Earth's surface. This bubble is called the ionosphere. That's a layer of charged particles that separates the upper atmosphere from space. In other words, this is the boundary that sets apart the region where you can still breathe and a complete vacuum of space. The International Space Station travels inside the ionosphere. Most of our satellites also move within the borders of the pulsating bubble. This natural phenomenon can both help and disrupt the operations of communication and navigation systems. It helps radio and GPS signals to get to our mobile phones, but it can also interrupt the stable connection. It all depends on the number and density of charged particles. Sunlight takes away 1 or 2 electrons from the gases surrounding our planet, and they become charged particles. These particles make up the ionosphere. It's constantly changing its shape and size. It happens because the planet rotates around its axis, and the sunlight falls on it unevenly. During the day, the ionosphere is always larger than at night. Because of this pattern, it's pulsating and constantly moving. This instability shortens the life of orbiting satellites and often puts them out of work. Radio and GPS signals pass through the ionosphere and get reflected from charged particles. Then, they fly further to their destination, to phones, navigators, and other devices with GPS and radio receivers. Our planet is not only pulsating, but also buzzing. The noise that Earth produces is called the hum. It's impossible to record this sound, but even so, 2 to 4% of people on the planet hear it. All over the world, people who aren't connected in any way speak about a weird buzzing sound. It interrupts their sleep and doesn't let them concentrate. This noise follows them everywhere. Perhaps you also hear it but don't pay attention. But once you notice the hum, you won't be able to unhear it. Some residents of a small village in Scotland describe this humming as a thick, low-frequency sound. There's a website on the internet with a map where people all over the world register and describe this mysterious noise. Almost everywhere, it's a low-frequency vibration, barely perceptible to the human ear. Sometimes, people say it resembles the noise of an airplane flying overhead, but quieter. Some people describe it as the sound of a running truck engine placed in the backyard. It's humming in the street when they come home. And it gets louder when they are lying in bed. If you hear it too, you can mark it on the map. There are records dating back to the 19th century that describe a sound similar to the hum. But for the first time, the media started talking about this phenomenon in the 1970s in England. Since then, many theories have been made by scientists and people who try to catch the hum. There is a hypothesis that claims the noise comes from high-speed traffic on highways, or it might be caused by too many airplanes flying in the sky. The hum and vibrations can be produced by electric stations, factories, industrial equipment, and huge air vents. Some people believe the reason for the hum is the movements of tectonic plates and the Earth's crust under the ocean waters. But no one has managed to prove it yet. In most cases, people hear the hum in big cities, and, of course, they often complain about this and demand to conduct investigations. But all the attempts to find the source of this noise haven't given any results. It's possible that 4% of people have a unique hearing that catches low-frequency sound waves. One theory says the source of the hum is special radio signals. They're used around the world to communicate with submarines. These radio signals can make people have a response. It feels as if you hear some buzzing. This happens when radiant energy collides with the soft tissues of the human skull. It stimulates the auditory nerve and creates an auditory hallucination. But the coolest theory appeared in the city of Sausalito in California. A lot of people there hear the hum, and biologists believe that fish might be the reason. There are many toadfish on the west coast. They can produce a unique sound that is not audible itself, but the sound wave coming from the fish resonates with the buildings located near the coast. This resonance produces the hum. Even one fish can do this. Imagine what happens when thousands of these sea creatures scream at the same time. But not only people living near the shore have problems with the noise. Those who live in the city center hear the hum too. And since the sound waves created by the fish can't spread so far, the theory was quickly refuted. Our planet isn't the only humming one. In 2020, scientists recorded a strange buzzing sound on Mars. This is a quiet, long beeping that spreads across the red planet's surface. Sometimes it changes a bit because of Marsquakes, which are another mystery. Earthquakes occur on our planet because of the tectonic plates' movements. Stress accumulates and gets released in the crust. This produces earthquakes. But there's no plate tectonics on Mars, so Marsquakes aren't supposed to be happening there.
So get this, Earth might be actually located near space highways that could connect us to other worlds. That's because our sun sits right in the center of a giant bubble filled with hot gas, carved out by ancient supernovae. And this bubble likely has tunnels linking us to distant galaxies. So, does it mean it's time to develop space tourism? Well, let's figure it out. Most of us think space is just planets floating around in eternal darkness. But new research hints at the possibility that it might not be really true. It turns out our whole solar system is actually sitting inside a giant bubble of hot, thin gas. And it gets even better. Scientists now think there might even be a weird cosmic tunnel or channel made of this stuff. It supposedly stretches out toward faraway stars. Astronomers spent years mapping the sky, and after they put all the data together, they found something that looks like a long pathway of hot, low-density plasma, which is basically that very thin, superhot gas. And this so-called channel reaches out from around us to distant constellations. Researchers from Germany confirmed this discovery using data from a space telescope called eRosetta. We'll talk about it a tiny bit later. Now, interestingly, scientists discovered that our solar system sits inside something called the local hot bubble a long time ago. This bubble is actually a huge area, about 1,000 light-years wide. It was created when several stars exploded in giant supernovas millions of years ago. Those explosions heated up the gas around them and basically carved out this bubble of hot, low-density space. And their shock waves created weak points in the bubble around us, eventually forming interstellar tunnels. That cosmic event was so huge that the leftover hot plasma is still floating around us today. Now, to understand this bubble better, scientists used eRosetta, which is an X-ray telescope. It scans the sky looking for soft X-ray light. That's a kind of light we can't see with our eyes. It comes from hot gas, old supernova leftovers, and other structures in space. They also compared eRosetta's new information with older data from another X-ray telescope called ROSAT. And finally, putting all this information together, they were able to make a much clearer map of what's around our solar system. Mind you, this wasn't easy. They had to divide the sky into thousands of tiny pieces and carefully measure faint signals coming from warm gas, empty pockets of dust, and other stuff floating in space. But their effort paid off. After sorting through everything, they managed to figure out the faint glow of hot plasma around us. It proved we were not just drifting through empty space. We're inside a giant burned-out bubble created by extinguished stars. But what really surprised scientists was the discovery of some kind of channel. It looked like a long tunnel in space, cutting through the hot gas around us and connecting our part of the galaxy to star systems far away. They also found signs of another channel pointing toward the Canis Major constellation. And those might not be the only ones. The data suggests there could be a whole network of such paths, branching out through space. Each one works like a hidden back road. Scientists used to guess that the space around our solar system might have little pockets or rooms carved out by old exploding stars. We could probably imagine them like caves inside outer space, but no one had the necessary tools to actually prove it. But now, thanks to that new data from the Rosetta telescope, they finally have a clear picture. The telescope showed that the space around us wasn't just empty. It's full of hot, thin gas and strange shapes, including tunnels and bubbles. This proves at least part of what older scientists predicted. We're living inside a giant bubble of hot gas, and that bubble connects to other bubbles through long, low-density channels. The new study also shows that the pressure inside our bubble is lower than scientists expected. This might mean the bubble isn't closed. It could be open in some directions, letting that hot gas flow out into other parts of space. In short, this hot bubble isn't simple at all. Parts of it might be open pathways, and other parts look blocked off. Being inside it is kind of like trying to walk through a forest. Some areas have clear trails, and others are packed with trees. And even though astronomers have mapped big chunks of the bubble and found these strange channels, there's still a lot they don't fully get. Some paths look like they're made of a bunch of connected empty pockets, and others look totally closed. To understand the whole picture, we'll need better tools and more data. Hopefully, with stronger X-ray telescopes, deeper sky scans, and better computer models, we'll finally understand the nature and structure of the bubble we're living in. We might be able to make a kind of map of those hidden channels and learn how they affect things like cosmic rays, dust, and the solar wind around us. Now, speaking of telescopes, we can't help but mention the one that helped us figure out the very existence of the bubble around us. The thing is, scientists have been trying to understand a faint glow of low-energy X-rays that seem to cover the whole sky. For many years, they weren't sure where this glow was coming from. And then, the NASA-supported DXL mission finally helped to solve the mystery. Researchers used old but reliable detectors that first flew on a rocket in the 1970s. With these instruments, they confirmed that most of this X-ray glow came from a huge area of extremely hot gas around us. It was named the local hot bubble. Back in the 1990s, another X-ray mission called ROSAT made pretty good maps of the sky, and it found something surprising. Comets gave off soft X-rays too. Later, scientists realized this happened when the solar wind, fast particles from the sun, collided with neutral atoms. This process, called charge exchange, can happen almost anywhere in space. Because of this, some scientists started to doubt whether the local hot bubble was really the main source of the X-ray glow. So, to test this, DXL launched on December 12, 2012 from New Mexico. The rocket flew high above Earth's atmosphere for about 5 minutes, giving the instruments a clear view of space. The goal was to look at a worst-case situation where lots of charge exchange might occur. Right now, our solar system is moving through a cloud of cold gas in space, known as the local interstellar cloud. That's also nicknamed the local fluff. Cute, right? Neutral hydrogen and helium atoms from this cloud move through our solar system at very high speeds. Hydrogen gets affected easily by different forces, but helium mostly follows the pull of the sun's gravity. Because of this, the helium forms a focusing cone, a region with extra helium that Earth passes through every December. This cone is the perfect place to look for charge exchange, since it holds more neutral atoms than usual. But what happens during charge exchange? The solar wind comes from the sun's corona, the star's superhot outer layer. The particles in the solar wind have lost many of their electrons. When one of these particles hits a neutral atom, it can steal one of the atom's electrons. The stolen electron briefly gives off a soft X-ray. This is how the glow is created. Now, to compare things, the researchers also looked at old ROSAT data from 1990 taken in a direction away from the helium cone, where charge exchange should be weak. By putting everything together, the scientists found that only about 40% of the soft X-rays come from inside our solar system. The rest, the majority, comes from the local hot bubble. This means the huge cloud of hot gas around us really is the main source of the X-ray glow. But let's get back to the discovery of the Space Intergalactic Tunnel. It's a valuable lesson for us that space might look calm and empty when we look up, but that's not true. Space around us actually contains dust, plasma, radiation, magnetic fields, and mysterious tunnels. All of these things mix and swirl together, making space much more complicated than a simple vacuum. So, we just spotted an asteroid so massive it could wipe out an entire continent if it ever hit Earth. And it's moving insanely fast, almost record speed. But what makes it really scary is how it's basically playing hide and seek with us. It can slip right into the sun's glare and vanish completely. And yeah, it just did it again. It disappeared. So, when we finally spot it again, will we have enough time to prepare? Or could it already be too late for humanity? Do I have your attention now? Thanks. So, meet 2025 SC79. That's a mouthful, so I'll just nickname it Scooby. This newly found asteroid is a sneaky one, the kind that loves hiding in the sun's glare. Think of it as trying to spot a firefly next to a stadium light. The brightness hits your eyes and outshines anything faint nearby. So yeah, you won't see that firefly. Now asteroids hide in the same frustrating way. When they end up close to the sun from our point of view on Earth, the glare overwhelms our telescopes, and the asteroid's dim, reflected light gets lost in it. That's why some asteroids can cruise along in the sun's direction and stay basically invisible to us. And scientists say the most dangerous asteroids, the ones that could wipe out a whole city, are the hardest to detect. That's why astronomers need to somehow dodge the sun's glare. One way they do it is by observing the sky during the short window of twilight. Right before sunrise or just after sunset. And that timing is a big deal, because it's the only way to catch some risky asteroid before it sneaks up on Earth. Scientists say that if one of these so-called twilight asteroids ever gets close to Earth, it could be a serious impact threat. And it was during one of these twilight observing sessions that scientists finally spotted this huge asteroid. It was September 27, 2025. Scott Shepard, an astronomer at a Washington-based institute, was scanning the sky, hunting for anything unusual in our solar system. And he had an incredible tool in his hands, the Dark Energy Camera, or DECAM, one of the most powerful sky survey cameras on Earth, built to spot faint objects across huge areas of the universe. At one point, he spotted a faint dot moving across the image. So he quickly aimed the high-tech camera at it, and things got more interesting. Its movement matched what astronomers expect from asteroids that orbit very close to the Sun. Then, follow-up observations with the Gemini and Magellan telescopes confirmed the discovery. Yes, this really was an asteroid, and there are two particularly curious things about it. First, it's fast, like really fast. In fact, it is the second fastest known asteroid orbit in the solar system. It loops around the Sun once every 128 days. For comparison, Mercury, the closest planet to the Sun, takes 88 days to go around once. Second, its orbit is super rare. This is only the second known object that stays completely inside Venus's orbit. That also puts it in one of the rarest asteroid groups out there, the Atiris. These are asteroids whose orbits sit entirely inside Earth's orbit. Astronomers have found only a few of them so far, and Scooby is the 39th one in the list. The team of scientists also figured out that this asteroid is pretty big, measuring about 2,300 feet across. That's roughly the size of Merdeka 118, the second tallest building on Earth. If an asteroid this size ever slammed into Earth, it wouldn't just be bad, it would be catastrophic. We're talking about damage on a continental scale. It would blast a huge crater into the ground, then throw out a shockwave powerful enough to wipe out forests and wreck cities. Seismic waves would ripple through the crust, triggering widespread earthquakes around magnitude 7.4, and people could still feel them about 300 miles away from the strike. And that's not all. A brutal air pressure blast would race outward, shattering windows more than 1,000 miles away. Then comes the aftermath. Dust and debris from the impact could shoot up into the atmosphere, block some sunlight, and mess with our climate. I know, you might feel scared right now, but don't worry about it. Thankfully, Scooby isn't going to do anything like that, because it's not on a collision course with Earth. Right now, the math shows it won't be making any close passes by our planet, at least not anytime soon. Still, there's a lot more to learn about this asteroid, but any further studies will have to wait. For now, it has disappeared behind the Sun and is out of sight. Once it reappears, astronomers will take a closer look and try to learn more about what it's made of. That part really matters, because this asteroid is somehow holding up while orbiting so close to the Sun's brutal heat. You see, this asteroid gets very near to the Sun. At its closest point, this asteroid is blasted with almost 6 times Earth's sunlight. At that distance, its surface could heat up to about 440 degrees Fahrenheit. What scientists don't know yet is how a rock this big can get baked over and over again without falling apart. And there are 2 more things astronomers want to check once it comes back into view: how fast it spins and how bright it looks. Now, by bright, I mean how much sunlight it reflects, because asteroids don't make their own sunlight. They're just big rocky chunks that shine by reflecting sunlight back at us. Anyway, those clues can tell scientists what Scooby is made of. One possibility is that this asteroid is loaded with dense metal, and that could explain how it survives the Sun's brutal heat. And if that turns out to be true, this asteroid could be a relic from when the solar system was just forming. Or maybe it slowly moved closer to the Sun because the gravity of Venus and Mercury gently pulled on it again and again over millions of years. Now, even though SE-79 isn't a real danger to us, and there's still a lot we don't know about it, just finding it is already a big deal. It's a reminder that big asteroids can hide from us. So even in our own cosmic backyard, there are still blind spots where large objects can stay hidden until the right moment of twilight gives them away. And as our detection tech gets better, we keep finding more and more asteroids. By now, scientists have spotted over 1 million in the solar system. They come in all sizes, from monsters like Vesta that measure about 329 miles wide, all the way down to rocks that are smaller than a house. Now, out of all the asteroids we know, about 40,000 are what we call near-Earth asteroids, or NEAs. That just means their orbits bring them close to our neighborhood. Technically, their closest point to the Sun is less than 1.3 times the Earth-Sun distance. It's close enough for planetary defense systems to keep a careful eye on them. And that's exactly why we can relax. I mean, nobody has to lose sleep imagining an asteroid slamming into our planet. Every time scientists discover a new asteroid that comes anywhere near Earth, they track it and run the numbers right away. And then they map out its path years, decades, or even centuries into the future. And they don't do it by guesswork. NASA's automated systems, like Sentry, constantly scan the asteroid catalog and calculate whether any of these objects has even a small chance of hitting Earth over the next 100 years. If something looks risky, it jumps to the top of the watch list and gets followed up fast. So yeah, there are almost 2,000 near-Earth asteroids that technically have some chance of hitting us in the next 100 years. But don't panic. Most are small and harmless, hey, like me. And their odds of impact are usually way under 1%. See why I said we shouldn't stress too much? Cool. Now, sleep tight. Wow, Astronomers just discovered that the solar system is moving way faster than it should. One trusted cosmic speedometer says we're cruising at a normal pace. But a new one says we're racing through space at a speed that should not even be possible if our physics are right. So it seems that either something out there is pulling us, or one of our basic ideas about the universe is seriously wrong. Now, when we move, things in front of us react more than things behind us. For example, if we walk through falling snow, the flakes hit our faces, not the backs of our heads. Ride a bike, and the air pushes harder in front, while the air behind feels calm. The front gets busier, the back gets quieter. That difference alone is enough to tell our brain that we are in motion. In cosmology, this front versus back pattern has a technical name. It's called a kinematic dipole. Astronomers use this principle when they measure how fast our solar system is moving through space. To do this on a cosmic scale, astronomers look at the sky the way we look at the world when we start moving. Only instead of snowflakes or air, they use distant galaxies. These galaxies sit so far away they barely change over billions of years. So they work like tiny markers frozen in place, perfect for spotting the difference between what's in front and what's behind. If the universe is smooth on the biggest scales, you'd expect the number of galaxies in each direction to be about the same. It doesn't really matter where the Milky Way is pointing or how we're spinning. The sky should balance out. But if our solar system is moving, one side might seem a bit more crowded because we're flying into it. It's the same trick as noticing more rain hitting the front of your jacket when you run forward. So, astronomers created huge maps of the sky using radio telescopes, which are good at picking up galaxies that shine in radio waves. Radio waves travel through dust, so the view stays clean. They counted how many radio galaxies appear in every direction to see if one side of the sky really is busier than the rest. And that's when they noticed something strange. The side of the sky we're moving toward was much more crowded than expected, like someone stuffed extra galaxies into that patch. This could mean we're moving faster than the standard model allows, or the galaxies are unevenly spread. We already know our motion from another source, the cosmic microwave background. It's the leftover glow from the Big Bang, and it works like a giant universal speedometer. For decades, it's given us a stable measurement of how fast the universe is moving. But this new result does not match that value at all. That extra crowding in the sky isn't supposed to exist at that level. Our best model of the universe says that when we zoom out far enough, the cosmos should look smooth and even. This result makes scientists scratch their heads. The pattern in the radio galaxy map was much stronger and more lopsided than expected. It lined up almost perfectly with the direction we're already moving, as if something out there was pulling harder than anything we've put into our models. Now, scientists just didn't look at one map and call it a day. They checked the result using several sky surveys made with different kinds of radio telescopes. One of those was LOFAR, a giant web of antennas spread across Europe that listens to the lowest, faintest radio signals, combined with two other large radio surveys. It's like taking 3 pictures of the same scene using 3 totally different cameras. If one of them added a strange color or distortion, the other 2 would catch it. But here, all 3 showed the same odd result. The dipole they measured is about 3.7 times stronger than what the standard model of the universe predicts. That's not a small calibration problem. That's a "your calculator must be broken" kind of difference. To understand how impossible this is, imagine checking 2 speedometers at the same time. One of them is the reliable one we always trust. That's the cosmic microwave background in this situation. It says we're moving at a normal speed. But the second speedometer suddenly claims we're going more than 3 times faster, like 200 miles per hour inside a parking lot. We would know something was off. Both readings can't be right. This is the problem. The CMB gives a solid decades-old speed, but the new radio galaxy result is showing something different. 2 measures that should match are telling very different stories. So what could be the reason for these broken calculations? Well, one idea is that the universe is not as smooth or even on large scales as our model assumes. We expect that if we zoom out far enough, everything should start looking roughly the same. But this result hints that the large-scale universe might be more uneven than that. Maybe some huge regions are a bit richer in galaxies, while others are emptier, and those differences add up across the sky, creating a dipole stronger than the standard model predicts. If that is the case, the extra radio galaxies are not a mistake. They are a sign that the cosmos does not follow the straightforward pattern our model assumes. Now, another idea is that something genuinely huge and nearby might be pulling on our whole region of space. No, sadly, not some giant space monster messing with our system from another dimension. The universe already has giant walls of galaxies, long chains of superclusters, huge clumps of dark matter, and massive empty voids that stretch for hundreds of millions of light-years. These things are so large that they can change how entire regions of space move. It's not a sudden yank, more like a slow, constant tug on everything nearby over a very long time. If there's something like that close enough, we can't see it. A wide stretch of space is hidden behind the Milky Way's own dust and bright stars. Astronomers call this the zone of avoidance because our telescopes can barely look at what sits behind that glowing band. We already know there's a large concentration of mass in that blocked region called the Great Attractor, which was my nickname in high school. And some researchers think something even larger could be sitting deeper in the same direction. Now, if that's true, then the strange pattern we see in radio galaxies might not be a mistake. It could be the first hint that something huge is tugging on our whole galaxy region, and we simply haven't mapped that part of space yet. Finally, the third idea is that something is off with the model we use to describe how the universe works. A model is just a big set of rules, like a recipe. Our current one explains dark matter, dark energy, how galaxies spread out, and how the cosmos changes over time, and it expects the universe to behave in a smooth, predictable way on huge scales. The radio galaxy result does not fit that picture. It behaves like a number that refuses to match the rest of the equation, so scientists have to take it seriously. It could mean that matter and energy spread across space in a way we did not build into the model. That would not break physics. It would just mean the rules need an update. So, what happens next? A bunch of powerful new surveys are coming online, and even though they weren't built specifically to solve the dipole problem, they're going to be extremely useful for checking it. The Square Kilometer Array and the Rubin Observatory are all going to map galaxies in way more detail than the older surveys we use now. With cleaner, deeper data, these instruments may help us determine whether the strong dipole is real or fades away when we look at it with better tools. None of these are special missions made just for this question, but the next round of observations will test it naturally. If this strange motion turns out to be real, then something big is shaping our whole region of space. If it's not, then we just learned something important about how easy it is to fool ourselves with patterns in the sky. Either way, we get one step closer to understanding the universe and its puzzles. Our planet has 5 oceans: the Pacific, Atlantic, Indian, Southern, and Arctic, not counting Billy Ocean. But it seems there's a 6th one out there too. It's just that you can't see it. Scientists have found evidence of large amounts of water hidden in the transition zone. That's the boundary layer that separates the upper and lower mantle of our planet. That boundary goes hundreds of miles deep down below the surface. Natural diamonds usually form in the mantle, but at depths of up to 155 miles. Some of them are very rare. They may come from deeper depths. That was the case with this fascinating diamond that formed 410 miles below the surface. The gem was big enough for scientists to study it and determine what it was made of. They were surprised when the composition of this very rare diamond showed that it was formed in pretty watery conditions. Because of that, such a diamond wouldn't be worth much in jewelry stores, but it was priceless in the lab. So, could this mean there's an ocean under the surface of our planet? It would definitely get us closer to the idea Jules Verne had about this whole magical secret world inside Earth, including the ocean. But that's not exactly the case. The water is there, true, but it's not like you can enjoy the view watching waves splashing around like on the surface of our planet. The water is actually stored within the minerals. That's why this area is so wet. Let's now move to Africa to keep up with the story, or to be more specific, to a spot called the Afar region. It's part of Ethiopia and a place where 3 tectonic plates meet. Tectonic plates are large pieces of our planet's crust that slowly move. These movements cause earthquakes and produce volcanoes, mountains, deep underwater valleys we call trenches, and so on. And the Afar Valley is where the Arabian, Somali, and Nubian plates meet. Together, they form an intersection in the shape of a Y. Why? Let me tell you. These plates are moving all the time. The Somali plate is moving southeast toward the Australian and Indian plates. The Arabian plate is moving north, getting closer to the Eurasian plate. At some point, it will close the Persian Gulf. This movement of plates has created something we call the Great Rift Valley, considering there are, all these cool rifts. The Aden Ridge to the east, the Red Sea Rift to the west, the Oculus Rift and the East African Rift to the south. But the East African Rift is something we want to focus on, because this one could be the key to this potential sixth ocean, but this time on the surface. A continental rift is a spot where 2 tectonic plates that form a single continent start to separate. Here it's the Somali and Nubian plates. Together, they're parts that make up Africa. If they keep moving in separate directions, this currently continental rift may become what we call an oceanic spreading ridge. In other words, when the plates are far enough apart from each other, there will be an enormous crack between them. This way, magma will freely flow up from beneath them. It'll be cool and eventually start creating a new ocean floor. Africa will be split into 2 parts, and there will be a new ocean flowing between what will turn into 2 mini-continents. Nope, it's not time to get your swim trunks and sunscreen yet. Even if the Somali and Arabian plates do move far enough to form an oceanic spreading ridge, it'll take millions of years before this happens. So I guess it's more interesting to stick to exploring this sixth ocean below the Earth's surface for now. The idea of subsurface oceans goes beyond the borders of our planet. It's possible many moons and planets out there have them too. Our home planet is the only one we know about with consistent bodies of liquid water on the surface, true. In our solar system, we circle around the Sun in something called the habitable zone. The temperature and atmospheric pressure within this zone allow water to remain in liquid form all the time. But a couple of moons in our solar system could also contain significant amounts of water under their surface. Enceladus, one of Saturn's moons, is the first one. Enceladus is a small frozen ball, 7 times smaller in diameter than our moon, but it's the 6th biggest moon of Saturn. Nearly a decade ago, a spacecraft found evidence that there was a large ocean under its surface. It found and sampled water from the eruptions that resembled geysers. A geyser is a rare type of hot spring that erupts and sends jets of steam and water into the air. Like Old Faithful in Yellowstone. Well, this water was erupting through fissures in the ice at the south pole of the moon. That means there might be a liquid ocean under the thick layers of ice. The ocean there is almost nothing like ours. The ocean on Earth is relatively shallow, on average 2.2 miles deep, and it covers 3/4 of our planet's surface. It gets colder the closer you come to the seafloor, and is warmer if you stay close to the surface because of the sun's rays. But the subsurface ocean on Enceladus is at least 18 miles deep. It's cooler at the top because that part is near the ice shell, and warmer at the bottom because of the heat coming from the moon's core. But both our ocean and the ocean on Enceladus are salty. Enceladus is one of the few places in our solar system that has liquid water, which makes it an interesting spot to search for signs of life. Another one is Europa, one of Jupiter's moons. Scientists think similar eruptions of water could be happening there. Knowing there are such geysers there tells us these moons have their own source of energy. Maybe the energy that makes the water erupt comes from gravity or radiation. The same energy could keep a large body of liquid water under the ice. It could even support some forms of life. There are thousands of planets beyond our solar system that orbit other stars. Some are even in the habitable zone. Over a quarter of the ones that we know about could have liquid water, but the majority of them probably have oceans under their surface, like Enceladus and Europa. Pluto might be on this list too, since it's possible it hides a liquid ocean under its thick frozen shell. This subsurface ocean likely formed long after the dwarf planet did, after the heat coming from radioactive elements in Pluto's core melted some of its ice. There's also something called water worlds. Those are moons or planets with global oceans that are more common than we thought. I mean, some call Earth a water world too. 71% of its surface is water after all. And when you look at our home planet from space, you mostly get those blue marble pictures. When exploring other planets, especially those outside of our solar system, researchers often go with a policy of follow the water. After all, water is the main element we know that's necessary for supporting life. And when there's a water world that's close to its parent star, scientists assume it must have formed way farther and then moved closer once its orbit shrank. The composition of the planet was set when it was in a colder orbit, or, in other words, when it made a wider circle around its star. We call the process of orbital shrinking a migration, and if water worlds are really that common, it can be proof that migration really happens. Exoplanets are all those planets that orbit around other stars, not our Sun. Some exoplanets may have oceans that are way deeper than any of those in our solar system, hundreds or even thousands of miles deep. Our Mariana Trench is scary, and it's not even 7 miles deep. And those exoplanet oceans are, wow, almost bottomless.